solving a three-variable system of equations. My first step is going to be to get all three equations in the same order, and it's best if they're in standard form or in the same order, so let's say x, y, z, but we'd like to have all the variables to one side unless you plan on using substitution somewhere. Elimination is in general going to be the easiest, so I'm going to rewrite all three equations. In this one, I add 3z to the other side, so it's going to be 1x minus 3y plus 3z equals negative 4. Here it's fine. It's in the order 2x plus 3y minus z equals 15. Here I need to subtract the 3y to the other side, and I'm going to put it in between the 4x and the z. So minus 3y minus z equals 19. So now I have equations 1, 2, and 3. Now, we said in class that it's always best if you look at 1 and 2 and do elimination, and 2 and 3 and do elimination. You by no means have to do that every time, but if you're staring at this problem and have no idea how to start it, this is a good way. So looking at 1 and 2, we want to see something that's going to be easy to cancel out. Now, just looking automatically, for 1 and 2 and 2 and 3, the y's are going to be easy to cancel out. Doesn't always work out that way. Sometimes you have to multiply the whole equation by something to cancel out the same variable, but I do have to cancel out the same variable for both. So I have x minus 3y minus 3z, plus 3z, equals negative 4. And the second equation, which is 2x plus 3y minus 1z equals 15. And I'm adding them straight down, which means the y's cancel, leaving me with 3x plus 2z equals 11. If I look at 2 and 3, and I rewrite them out, again, I didn't have to multiply by anything because the y's are automatically going to cancel out again. The y's cancel. 4x and 2x gives me 6x. And a negative 1z plus a negative 1z gives me a negative 2z. Don't be too quick to cancel things out. 15 and 19 is going to give me 34. So now I have two new equations. I'm going to take those two new equations and solve that system because they both have x and z. So I'm going to multiply if I have to get one of the variables to cancel out, but if you notice, this has a plus 2z, this has a minus 2z. So I'm automatically going to have things canceling out. So if I add them together, it's going to be, and some people like to number, like this is equation 4, and this is equation 5, and then they can label that they're doing 4 and 5, and that's fine as well for organizational purposes. 3x plus 2z equals 11, and 6x minus 2z equals 34. We're adding straight down, and the z's are canceling nicely. 6x and 3x gives me 9x, 11 and 34 gives me 45. When I divide both sides by 9, I get that x equals 5. Now I'm going to take that x equals 5 and plug it into one of these two equations that I created, so to my 4 and to my 5 equation. Doesn't matter which one, let's say into 4, because there's smaller numbers there. So it'll be 3 times 5 plus 2z equals 11. So I get 15 plus 2z equals 11. I subtract the 15 to the other side, and I get that 2z equals negative 4. And when I divide by 2, I get that z equals negative 2. Now I take the z, the x, and plug it into any of my original equations. You can plug it in here or here. They're the same exact equation, but some might just be easier than others. So I'm looking to solve for y. So let's take the third equation. Again, it doesn't really matter which one, but it's 4 times 5 minus 3y minus that negative 2 equals 19. So that gives us a 20 minus 3y minus negative 2, if we keep change, gives us plus 2 equals 19. Combine like terms, so we get that 22 minus 3y equals 19. We subtract the 22 to the other side, and we're going to get that negative 3y equals a negative 3. Divide by negative 3 on both sides, you get that y equals 1. And since it's not a word problem, we're writing our answer as coordinates in the order x, y, z. So 5, 1, negative 2 is our final answer. And again, we're writing those as coordinates, so in our parentheses. If it were a word problem, then you would have to say 5 of these, negative 2 of these, 1 of these. You'd have to actually label them. And again, there are many different ways to solve this. We can choose different equations. I don't have to do 1 and 2 and 2 and 3. I can do, let's say, 1 and 3 and 1 and 2. I can do different combinations. I can multiply by numbers to cancel out different variables. There are many different ways to solve this system, but if you don't know how to start, look at 1 and 2 and 2 and 3. Cancel out the same variable in both. You're creating two new equations, 4 and 5. You're solving that system for one of the variables. Your answer you then plug into 4 or 5. And then you solve to get the second variable, and you take now both of these and plug them into any of your original. Write your answer as coordinates.